specifically the blenny would have to be one of the world's most remarkable fish. The locals here on Guam refer to them as monkey fish, and for good reason. You can find them popping from rock to rock in high abundance in the intertidal zone all along the coastline of the island. And these fish are land-dwelling fish. They spend almost all of their time out of the water on the rocks, foraging, courting each other, and even defending little territories.
There is a whole range of different strategies in the natural world that males use to attract females. A lot of those strategies rely on males being as showy as possible. Sometimes it's the type of song they produce, but often it's the type of morphology they exhibit. A lot of the extravagant morphologies in the natural world is driven by female mate choice. Females becoming increasingly choosy with which males to mate with, and males having to evolve large ornaments, for example, or extravagant behaviour such as courtship to try and entice females to mate with them and not some other male. And we can see this in the amphibious blennies. On land, males defend little territories and also spend a lot of time trying to entice females to mate with them. They do this by finding a really nice rock hole, which can be used as a nest, and they spend time at the front of that rock hole, head nodding and displaying a large, prominent head crest. When they see a female approaching, males will also flash their dorsal fin, which is frequently coloured bright red. And what they are trying to do is advertise to females their quality as a mate. If a female decides on a male to mate with, she will enter his rock hole, lay her eggs, and he will fertilise them, and he will then guard those eggs until they hatch in a couple of weeks' time. A male's quality is advertised by not only the size of an ornament, for example the size of the dorsal fin or head crest, but also its coloration and its saturation of red. This red is also very conspicuous against the rocks blennies are typically displaying against. So there's an additional benefit as well, not only advertising a male's quality, but also being very detectable in the environment. What we've discovered is that you can go to different islands throughout the Pacific Ocean and the Indian Ocean where terrestrial blennies live. They're all different species, but they're all closely related to each other. And you'll see that the size of the head crest and the size of the dorsal fin, the coloration of that dorsal fin will often vary quite dramatically from species to species. And so we can investigate why this might be so. First of all, we can demonstrate that females are actively selecting among males depending on the size of ornaments. We can create a model male blenny, put it in an artificial nest, and attach that nest to the rock wall to simulate a male hanging his head out of his rock nest. The size of the head crest varies between those models. And through observation, we find that females spend a lot more time with the model with the largest head crest. The other thing we can do is we can estimate the ratio of males to females. If the sex ratio is male biased, there are a lot of males in that environment that are competing for few females. So, female mate choice will be particularly strong because the competition among males to attract those females is especially intense. We can estimate a population sex ratio through quadrats, and we do this by tying string onto the rocks in the intertidal zone at low tide, and then coming back at mid-tide when the blennies are most active and simply counting the number of males relative to the number of females in those quadrats. We do this many times and we can estimate the likely sex ratio for that population. We can use that sex ratio as an index of the potential intensity of sexual selection acting on males and compare it across different species. When there are a lot of males, so sex ratios are heavily male biased, we tend to find those males exhibiting the most extravagant morphology, very large dorsal fins, or those that are very colourful and saturated with red and have very large head crests. And this reflects the influence of female mate choice within species for increasingly elaborate ornaments. In aquatic environments, there is a cap on the size of the dorsal fins and head crests. It's all used in swimming, but obviously the land fish don't have this constraint anymore because they don't swim anymore. They live out on land. So this constraint on the size of the dorsal fin and head crest has been removed.
So on land, these fish lead a very precarious lifestyle. First of all, they need to be able to breathe. And the way that they do this is they need to stay within that splash zone of the intertidal zone. And this is because they need to remain moist. Their entire body needs to remain moist and their gills need to remain moist. They still breathe through their gills like other fish, but they also breathe through their outer skin. And to facilitate that, they need to stay wet. The fact that these fish are apparently exclusively terrestrial, that is, they spend the vast majority of their time out of the water, living on land, and really do not like going back into that ancestral marine environment, opens up a really exciting question for us. Now, around the island of Guam, we have long stretches where we have these rock outcrops in the splash zone where we find these terrestrial blennies in high abundance. But separating those rock outcrops are long stretches of beaches. Now, those beaches may be wonderful for holiday makers, but they're an absolute nightmare for these terrestrial fish. These fish will not be able to cross those beaches. So if they don't go back into the water, this implies that these populations separated by these beaches are actually geographically separated. Now, evolutionary biologists get particularly excited about populations that are geographically isolated because difference in selection pressure between those populations can actually lead to evolutionary divergence. Now, if evolutionary divergence persists for long enough and is strong enough, we can actually have the formation of new species, what we term speciation.
We can also investigate differences in ornamentation among populations of the same species. For the land blending on the island of Guam, we can visit different populations around the island, and we find that the size of the head crest and the size of that dorsal fin, but in particular the intensity of red of that dorsal fin, tends to vary. This also reflects differences in sexual selection within species, but also natural selection through predation. So again, we can estimate the sex ratio for all of these populations on Guam, and we see that as competition for females increases for males, so sex ratios become increasingly male biased, the size of ornaments, and in particular the coloration of the dorsal fin, becomes larger and more intense. But in the same way these ornaments are conspicuous to potential mates, they are also obvious to potential predators. We can estimate the predation pressure that populations might be exposed to by putting out plasticine mimics. Birds, rats and other predators will attack these plasticine blennies, leave impressions in the plasticine, and we can use the extent those blending mimics have been attacked to determine what the likely predation pressure for that population might be. What we find is, as predation increases across populations, the level of intensity of red in that dorsal fin becomes reduced. So there's a trade-off. Males are trying to attract females, but they are also attracting predators. And what they are doing is balancing that benefit versus cost by changing the expression of their ornamentation. So, this is an example where differences in selection pressure among populations of a species could lead to divergence in reproductively important traits, here ornamentation, and this could ultimately lead to the evolution of new species.